Hi, my name is Paul DeGuiseppi. Many of you may remember me as the former manager of service training at MAX, the Mobile Air Conditioning Society. We're here today to discuss the differences between R1234yf systems and R134a systems, brought to you by Honeywell, and this is program number 2 in a series of 3. Here's specifically what we're going to cover in this program: R1234yf systems versus R134a systems, the component differences that what you will see on an R1234yf car versus a 134a car. We're going to talk about system operating characteristics, the slight differences in operation between an R1234yf system and an R134a system. We're going to discuss the flammability of R1234yf. You may have heard that the new refrigerant is mildly flammable, not much to be worried about there. We're actually going to go to a vehicle equipped with an R1234yf system and show you the slight differences in the components, service ports, things like that. Lastly, we're going to give you a list of vehicle manufacturers that are currently using R1234yf in their vehicles. So what are the differences between R1234yf systems and R134a systems? There's really not many differences between an R1234yf system and an R134a system. There are slight design differences in certain components, such as condensers and expansion valves. The main things that you are going to see as a technician when you go to work on one of these new systems: the service ports are different. This is, of course, to prevent the mixing of the different refrigerants together. The evaporators used in R1234yf systems must meet an SAE spec. That would be SAE spec J2842. That's not something that we've had with R134a systems. One difference that you are going to see on many R1234yf systems, not necessarily all of them, but probably most of them, is that they're going to be equipped with a component that you haven't seen on R134a cars, although some of the later R134a designs did incorporate them. It's a device called a suction line heat exchanger. Some vehicle manufacturers refer to them as an internal heat exchanger. It's basically an inline device that serves as a state change helper, helps the system operate more efficiently. It's a device placed in line before the expansion valve. Let's go take a look on the car. We'll show you what that is. So here's our service ports, and first thing I'd like to point out is we've unbolted and tied back our coolant reservoir and our power steering fluid reservoir so we can get a nice, good shot in here to get a look at the ports as well as the suction line heat exchanger that we're going to be talking about in a moment. But here's, on this particular vehicle, here's the high side service port. Our low side port is buried way, way back in here, as you can see. But the main thing that we want to point out is that these ports are dimensionally taller. They are still quick couplers. You can probably better clearly see that by looking at the actual hose couplers for the service equipment. Here is a R134a high side hose coupler versus an R1234yf machine hose coupler. And you can clearly see that the one for the R1234yf machine is much taller in comparison to the R134a machine hose coupler. So, of course, the reason why they do this is they don't want you to be able to connect an R134a machine hose to R1234yf system. So that's why they have made the ports dimensionally different. The last thing we want to show you on the vehicle is the suction line heat exchanger, or some vehicle manufacturers may refer to it as an internal heat exchanger. Now, this is something that you typically haven't seen on R134a systems, although some of the later designed R134a systems may have them. But nonetheless, this is something that is more particular to R1234yf systems. And it's this device that you see right here. It's essentially part of the line assembly, doesn't have any moving parts. But let's take a look at it and explain why it's here and what it does. So you can notice that the high side line leaving the condenser containing the warm liquid refrigerant sort of comes up here and enters the suction line, as you can see right here. And what they're essentially doing is they're allowing the cool vaporous refrigerant that is leaving the evaporator to surround the warmer liquid refrigerant leaving the condenser to further cool it or subcool it before it reaches the expansion valve and then subsequently the evaporator. And the idea behind this is it slightly increases system efficiency and allows the 1234yf system to give you the same cooling performance or similar cooling performance as an R134a system. So once again, not necessarily every R1234yf system will have the suction line heat exchanger, internal heat exchanger, but many of them will be equipped with these. Once again, no moving parts, part of the line assembly. If the line assembly needs to be replaced, the suction line heat exchanger comes with it. Another question you might have, what about the differences between operating pressures and component operating temperatures of an R1234yf system versus an R134a system? The answer is they're really not that much different. The same way that when we made the transition from R12 to R134a, the way those things were very, very similar, it's essentially the same thing with moving from R134a to R1234yf. Not much of a difference between system operating pressures and component operating temperatures. As a matter of fact, here is a pressure temperature chart of R1234yf versus R134a. And taking a look at the chart, you'll notice that the curves run very much together. You can see that basically all the way down to about minus 10 degrees F, all the way up to about 150 degrees F, and that's when they start to split off a little bit. But the bottom line is you can see that the PT curves of both of these refrigerants are very, very similar to each other. So what about the flammability of R1234yf? You may have heard that it is flammable. Well, yes, it is flammable, but it's mildly flammable, meaning that it could ignite if it would come in contact with, say, for instance, an open flame or an extremely hot surface. It's classified by ASHRAE as a 2L flammable gas. That means that the gas, the refrigerant itself, has low burning velocity and low heat of combustion if it were to ignite. Let's talk about that low burning velocity in a little bit more detail. Essentially what that means is if the gas were to ignite, it would travel through space in air at a speed of less than 10 centimeters per second. So as compared to other chemicals or gases that you're used to working with in the shop, that would be an extremely slow-moving flame. So speaking of the flammability of chemicals, let's take a look at this chart. In the upper right-hand corner are chemicals that you are familiar with, such as gasoline, propane, for instance. Let's contrast those with the chemicals that are listed in the lower left-hand portion of the chart where you see R1234yf. What the chart is essentially illustrating is chemicals that you know are highly flammable, and if upon ignition would move through space at a relatively high rate, contrasted with those chemicals in the lower left-hand portion of the chart, such as R1234yf, which upon ignition would move through space very slowly with lower impact. And one last chart to simplify. This one lists chemicals that you would typically find in a workshop, gasoline, diesel fuel, engine oil, for instance. If you look at the comparison of R1234yf on the far right-hand side compared to those chemicals, the impact of the flame, if these chemicals were to ignite, the impact of the flame of those chemicals would be much greater than R1234yf. And the chart also illustrates that there is less 1234yf in the vehicle in comparison to those particular chemicals. So in conclusion, out of all the flammable chemicals in your shop, R1234yf is one of the least of those. When working with R1234yf, similar to what we would do when working with R134a, we always want to employ the same common sense safety practices and procedures, such as adequate ventilation, no smoking, vehicle doors and windows open, no open flames or other ignition sources. Be careful when grinding, welding, doing things like that. No incandescent work lights. Make sure that you have properly operating fire extinguishers and that everyone in the shop is properly trained in the use of fire extinguishers and all the other safety equipment that you have on hand. As with all chemicals you have in your shop, you should have the safety data sheet on hand for R1234yf, which instructs you what to do should something go wrong. You're probably curious about which vehicle manufacturers are using R1234yf. As of this taping, here's a list of those. The number of models using R1234yf from these manufacturers will continue to increase as years go by. As mentioned previously, this is one part of a three-part series brought to you by Honeywell, which brings you information on R1234yf. There are some additional resources that you can take advantage of, as well as Honeywell's smartphone app that brings you more information about their refrigerants. I'm Paul DeGuiseppi. Thanks for watching this program on R1234yf systems.